Hello and welcome back to RC Model Reviews. Today I'm going to talk about bearings and lubrication, and you might think, oh, what's that got to do with anything? Well, we're actually using bearings in a lot of places these days in our models. Of course, if you've got any kind of electric power, you've got bearings in the motors. If you've got nitro power, you've got bearings in the nitro plane. If you've got helicopters, you've got bearings in your helicopter. So yeah, the whole gamut, multi-rotors have all got bearings in them, and even a glider has bearings in it. Because if you've got good quality servos, they've got bearings in them. And so yeah, bearings are ubiquitous, which is a big word that means they're everywhere. And I'm going to talk a little bit about bearings before I talk about the subject of lubrication. First of all, there are three main types of bearings, and here they are. We've got open bearings, which is what you see there. And in the open bearing, you can actually see the balls in these ones. Open bearings are used where you have no chance or very little chance for contaminants or dirt or grime to get in, and often they're used in an environment where there's lots of oil about. So you'd find these in the crankcase of a gas motor or a nitro motor, glow motor, because they need to be exposed to the air-fuel mixture that's coming through, which carries lubrication with it, and then you shouldn't get any dirt going into the crankcase of an internal combustion engine. So these open bearings are the way to go. Benefits of an open bearing are there's no drag, there's nothing, the only places friction is where the balls rotate against the inner race and the outer race, and that's only a very small rolling friction. So these are very low drag bearings, and they can run at quite high RPMs. Which is why you have them in nitro motors, I suppose. So there you go, that's open bearings, the simplest type of bearings. Now, worth noting that these open bearings have a number of components, and those components are, as I mentioned before, there's the inner race, there's the outer race, there are the balls themselves, and there's also something that holds the balls in place. There's a thing called a retainer. Now, normally retainers in most bearings are made of brass or some kind of metal, but this is a plastic retainer, a polyamide they call it, retainer in here. As you can see through it, you can see the balls through it. And the reason this one has a plastic retainer is because it's designed for use in the crankcase of a nitro motor, a glow motor. And what can happen in glow motors is you get a lot of corrosive byproducts from the combustion process. The nitromethane can create very acidic, very low pH chemicals inside the crankcase, and that will eventually cause the metal cage, if you have a metal retainer, it'll corrode and it may break up, and once it breaks up, then the bits of metal can come out and the balls themselves can come out, and you get all sorts of problems with balls trying to go through transfer ports and things. So in an internal combustion engine, a plastic retainer is a wonderful thing because first of all, it won't corrode, and secondly, even if it does break, the bits of plastic are not going to do nearly so much damage as bits of brass or steel in a conventional bearing. Now we have another very common type of bearing, and you see it's the same. We've got an inner race here, we've got an outer race, but you can't see the balls in this one. It's shielded. There's a metal ring here which actually shields the balls so that large contaminating bits of metal or grime or dirt or rocks or small children can't get in there to upset the movement of the balls. It's not going to get gritty and dirty and whatever. So shielded bearings are used where there's the possibility of large size contaminants getting into the bearing and ruining it. Now, you might think, well, why don't you use one of these? Because this looks very similar, doesn't it? Now, this is what we call a sealed bearing. And a sealed bearing, it looks like a shielded bearing, except instead of having a metal ring, it's got a plastic or sometimes a rubber ring. And what happens here is this ring actually is sealed. So it seals the inside of the bearing. So there are a couple of benefits to that. Even the smallest bits of contaminant can't get in here. So if you're working in a very fine, dusty environment, then fine bits of dust might just get into the shielded bearing, but they're not going to get into a sealed bearing. The other benefit is that because the shields are not a perfect fit, if they were, you couldn't turn. I mean, because if you had metal on metal, it would wear and scrape and grind if you had these shields rubbing hard against the two sets of races. With these ones, because we've got plastic or rubber, then you can actually have those completely touching both races to give you the seal. That means that in here, we can put lubricant in here and it will stay there. Put some grease in there, it will stay there. It won't be able to get out because it's sealed in. So where we have bearings operating in very, very, what would you call it, difficult environments where there's dust and dirt and things, and where you're not going to be able to get at them to lubricate them, sealed bearings are the ones you want. So sealed bearings are great for a lot of applications, in fact, huge numbers of applications. Normally they are sealed with grease in them and it's sealed for the life of the bearing. You don't have to worry about it. So what are the downsides? Why wouldn't you use a sealed bearing all the time instead of a shielded bearing? Well, there's a thing called drag. As I mentioned, these shields here, they can't actually touch the metal themselves, so they can't provide, or these shields can't provide a proper seal. So where you have a seal, you have drag, and the drag means that this bearing is harder to turn. It's going to be harder to turn. It's going to have more friction than this bearing, because these seals are actually rubbing against the races, and that means at very high RPMs this will absorb more of the power. It won't be as efficient a bearing because there's friction not only between the balls and the races, but between the seals and the races. So yeah, we don't use these all the time, even though perhaps you might think we could. But there we go. So the most common bearings you're likely to find outside of model engines are these two. Now, in some things like helicopters and so forth, you may find seal bearings for the various bits and pieces in the rotor system and in the tail rotor system, because they're not moving much. The pitch and things are not moving much, and you want to keep the grease in there. You don't have to keep lubricating them, and because there's no high RPMs involved, seal bearings are great. However, for electric motors, you want a shielded bearing, because you don't want that drag there. And also another thing to remember is that these are usually packed with grease. And grease, as you know, is quite viscous. You look at grease, it's like a cream. It's you can put your finger in it and it'll come out on your finger. Whereas oil is very runny. And so where you get high speed, you want something that's really runny. Because imagine, the consideration is, if you run through the air, you hardly feel it. Try running through water in a swimming pool, you can hardly move. So this is like trying to run through a swimming pool, this is like trying to run in the air. The viscous drag, as it's called, from the grease in these bearings will, again, consume a large amounts of power, make it harder for the bearing to turn. And although the grease will stay in there for the life of the bearing, it's not going to be the best lubricant at high RPMs. So that's why we have shielded bearings for our electric motors. It enables us to protect the bearings from most of the dirt and grime that you're going to encounter, but it doesn't have to be loaded with grease because you can re-lubricate them. They come with a fine film of oil, but because it's not a perfect seal, that oil will eventually get out of the bearing. So from time to time, you're going to have to put some oil in there. They're not lubricated for life. And that brings me to the reason for this video. Now that I've covered all the bases and told you about bearings, I'm going to talk about this. Okay, what is this? Well, it's a bottle of green stuff, of course, and no, it didn't come out my nose. It is actually, well, I call it Taro RC Speed Bearing Oil. There you go. So what exactly it is, I don't know. It's supposedly a high-speed bearing oil, and you can tell it's high-speed because look how runny it is. It's not like a thicker oil you'd use in your car, and the reason it's thin is because, as I mentioned before, you want a very thin oil in a high-speed bearing, otherwise you get that running through water situation. Even worse, if your oil is too thick, then the balls won't even rotate, because as the bearing turns, and we'll use the open bearing to show this, as the races turn, you can see the balls are actually moving around. And what happens is, if the oil is too thick, or if you have too much oil, then a little wave of oil builds up in front of the balls, and eventually the pressure from that wave forces oil under the balls so that they're no longer touching the races. And so they actually aquaplane, they skate across the surface of the race there. And when that happens, they can from time to time touch, and it causes very, very small micro galling, small pitting on the races. And if that happens, it creates a rough spot. So next time around, it creates more wear, and bits of metal start coming out. So the oil you use for oiling your bearings, your high-speed bearings, has to be the right oil, and you have to apply the right amount. Now, as I say, this is one I got from Banggood. Okay, now Banggood's an interesting company. I've bought stuff from them before. They keep sending me emails saying, we'll give you free stuff if you review it and say nice things, and you can even earn money from an affiliate scheme. And I say, no thank you, that's not the way I work. So I went and bought this. It was pretty cheap. And I'm going to be using it in a number of things. My mini quad bearings, because I do lubricate the motors in my mini quads. I'm going to try using it over a period of time and just see what difference it makes. I've got mini quad here. I'm going to lubricate the motors on one side with this, and I'm not going to lubricate them on the other side. And we'll just see if it extends the life. It comes with a hypodermic, so there you go. It can be used. It's a very fine hypodermic, 2 millimeters, and it's a very fine needle. And I'm sure that if you wanted to, you could inject the stuff straight into your bloodstream and kill yourself, but it's not a good idea. Getting hold of a hypo these days can be hard enough. I know that, there's, because you could be a druggie, there seems to be some kind of, you can't have a needle unless you've got one to exchange. But so this is good. It's a nice little package. You get the hypo, you get the oil, and I don't know how much is in there, probably, oh, goodness knows, doesn't say. Anyways, heaps. Because you only use a small amount, for example, on an average motor bearing, you'd use probably 2 drops, and you'd do it every 15 flights. So in the case of a mini quad, for example, since I'm building a mini quad, I would oil it at the end of each day. End of each day's flying, I'd put a couple of drops on each motor, give them a bit of a spin, and then by the time I go to fly it again, the oil will have wicked in through the seals, or through the shields here, into the balls inside, and it'll be ready to use. don't flood the bearing, don't waste it. So this, if you're only putting 2 drops on each motor, there's 8 drops per flying session. This will last an awfully long time. Is it any good? I don't know. I don't have the chemical analysis gear here to determine what it is. It could be just, I don't know, it could be water, but it's a bit thick for water. So that's why I'm going to test it out, let you know. But in the meantime, someone may have already used the Taro. I mean, Taro is a recognised brand if it's the same Taro that we know from the multi-rotor world. So one would hope it would be good. How we go. And I will report back later on this. But in the meantime, if you want to buy it, there is a non-affiliate link in the description so you can go and get it where I got it and try it out for yourself. So thank you for watching. Questions, comments, if you've used this stuff and it's crap, or if you've used it and it's good, let us know so that I don't have to waste motors, or at least I can save some motors by using it. In the meantime, thanks for watching. Time for me to get back to the bench. Bye for now.